basically, what I have here for people today is just like a working implementation of stable video diffusion. So it's not like using the HuggingFace library, it makes things fairly straightforward to use if you're used to using the library. Those were 3 minutes with the most computing power that I ever had. Maybe loud, thanks. So the basic sort of formula for HuggingFace implementations is going to be loading your pipeline, setting your variables on that, and then tokenizing your prompt, and then running the actual inference on it. And this is pretty much true for every single kind of inference that HuggingFace offers. Their library is excellent. So if you have a chance to dig into the library, you can run all kinds of different models. And once you get through one or two of them, you're basically unlocked all of them. So that's really cool. To just give you an example of what we're actually going to make, or what it actually does. So this is just an image that I made. I found out that if you overcrank the CFG on diffusion models, it makes really good like psychedelic images for people who know what that's all about. But then if you animate them,
that is a kind of a a reference.
If you know, you know, and if you don't, that's cool.
Yeah. You don't know what you're missing, right? So
yeah.
Okay.
So this is basically it's running through a pipeline. So it will take the image and does an image to image, and it does it repeatedly to create the actual video, and then it will output a video, and then after that, it will turn that video into a GIF, or GIF, or I like to pronounce it JIFE, just to annoy both sides. So just let this go for a second here, and you can look at the really creepy eye.
So that's what it's doing in your pipeline right now, I guess? Is it just building them up on about frame by frame or whatever?
Yeah, so right now it's just running inference. So there's 25 steps. So there's 25 full images that are being made in sequence. And then those each have 2 different stages, because I'm using Stable Diffusion. So it's 27 and then 8 respectively. So all these are in the settings of the different inside of source. There is Stable Diffusion XL and the Stable Diffusion video.
Can we maybe back up a little bit for people that aren't quite as familiar with Stable Diffusion? And can you do maybe just a couple of minutes on?
It's a duck.
Hey, it's a duck. Maybe just kind of can you do a couple of minutes, just kind of high level kind of thing of what you're doing with Stable Diffusion, or what Stable Diffusion does? If that's okay.
Yeah, for sure. So Stable Diffusion is a image to image diffusion model that will perform, what is it? It basically will take noise out of an image in multiple passes, taking a little bit more noise every time. And the noise sort of looks like static. And it will do that repeatedly until eventually it will render an image. So there's like a whole training process with it. We went over it in previous classes, talking about like all the different steps. And yeah, I can show you a working example of it. So let me grab this thing. Okay, this one, template, Stable Diffusion XL, grab this guy, and then where are all my boxes? Where are my boxes? Okay, of course it doesn't have the thing. Let me see here. Load. Let's take the cat. This one's good. And so you can see a working example of it here. This is like a pretty complex pipeline. So you have your prompts that go in. This is your positive prompt. This is your negative prompt. You have models that lead. This is a LoRa. This is a implementation of FreeU, if you know what that is. It's like I don't actually know exactly what it does, but it makes your models produce better images, and it doesn't cost you any compute or anything else, so I use it. And then there's like a whole detailer pipeline that's attached to the end. So this is where the actual diffusion happens. So for the video diffusion that we're doing here today, basically we're just using this. So all of this extra stuff is pretty much just extra peripheral stuff. And you can see the images get generated. I'm gonna do this. Turn that again. Let's be upset about my model. And select. Where is it? Game Shipper. That guy.
Hey, Richard.
Yep.
Do you know for the video generation, you said that the Stable Diffusion is image to image, correct?
Yes, it's image to image, and it does it multiple times.
Okay. And so when you're doing video, is the image generation conditioned on just the prior, or is it conditioned on multiple prior images?
So there, with the Stable Diffusion video, it is just the prior. If you want
Just
to use
kind of one
another,
step.
yeah, I know there's another library that's called animated diff, and then there's a couple other sort of like variations on that, and those ones are set up to, they do like they take they take the last one that happened and the one behind it, and then they interpolate between the two as
Okay.
well. So
Kind
then
of
that
a,
makes a lot smoother videos. This one is just like straight trained on the it's just straight trained to make video clips. So it like makes specific, so there's a model that is that makes 16-second clips, and there's a model that makes like 25-second clips, and so those they're like trained specifically to make that specific length of video. So it will always do that all the time. So I think the way that Stable Diffusion has done it, they've like actually conditioned the model to like respond to images and create them and like interpolate between them within the training, as opposed to inherently doing it like externally from the model, if that makes sense.
mhm.
So we'll run this one
Cool.
more time, and then yeah. So I'm not sure if we want to go through the code. It's kind of boring to like watch someone like show you code.
Sure.
Well, unless you've never seen the code before.
Yeah, yeah.
I guess, yeah, that's
Feel free to bore us.
yeah. Okay. All right. So yeah, and if anybody wants to play around with stuff afterwards, like you can come talk to me. Like I don't mind letting you use the instance, and I can show you or whatever. But yeah, so we have a few different pieces in here. I'm not going to go over the API that's included in it. So this is just an implementation of an API that you can run if you like, and then you'll be able to hit that endpoint with like a client, and it send it an image, or you can send it a prompt, and then it will be able to generate the image for you. So like if you want to try to have a implementation of an API somewhere, that is available, as well as I can also give our inference endpoint and let people use that if they want. If you're good with the client, you can basically just ping it and get image to video whenever you want. So that will be a thing that people can ask me for later. And then, oh, go ahead.
So so the idea there then is that I would have a client on a low compute machine, my laptop or something like that. I'd make an API call sending an image, and I'd get back the
Like this.
image or video.
Yeah.
Okay.
And so it basically just takes it, and then it just sort of like interpolates, like it sort of looks at the image and sort of guesses what it's supposed to do. But like it's pretty impressive, honestly. For like it's a fair amount of compute. Like it's not something that a lot of people can run locally without having a fairly good GPU, but it is like still reasonable within like home household GPUs. You don't have to get like an A100 to just run it or something like that, which is nice because like $20,000 for a GPU is a little bit much for most people.
So what do you just out of curiosity, what would you need? Like a 4000 series or something
Yeah,
like
you'd
that?
probably want to like a 4090. I think one of the best, if you're on a budget for doing like ML stuff,
Hmm.
and is to go out and buy two 3090s from a crypto miner that is trying to sell all the rigs. Because you can get like cards for like $300, and then you put two of those together, and you got like what, like 48 gigs of RAM, which is pretty good.
Hmm.
And then they also have MV Link, MV Link, so they can communicate and do parallel processing as well. So you can do distributed across two cards without actually like just out of the box.
Cool. Okay, thanks.
Yeah. So getting into the actual code of Stable Diffusion itself. So if you're not super duper familiar with Python, I'll try to like explain everything, but I'm not going to go into like super crazy detail on like what a function is and stuff like that. If you do have questions, feel free to ask. What's the minimum VRAM requirements needed for SD video? Let's find out. So let's give it another prompt, and then we can actually like look at the GPU stats. Where's this? So we'll do this, and we'll give it a prompt, and we will say, what do we want? Somebody give me a suggestion.
A person running down the beach or something like that.
Okay.
Can you do it?
Yeah, sure. Someone running down the beach in their summer bathing. I want to make sure I give them clothes.
Okay. Yeah, let's keep it PG here, man.
Yeah.
Thank you.
All right, so that can go, and then we can get out of my way. Be careful with that. Okay, so Python main.py. Oop, something's wrong. I have not put a none here. There we go. Try that again. Oop. So while that runs, we can take a look here. And we can go GPU stat. I. We can take a look. So we're using about 19 gigs of RAM when it hits peak. So it's like over. It's basically a 4090 is what you'd need for this. Because you can go over it and you can store. There's like techniques for being able to store your excess memory in RAM, as well as like you can quantize models and stuff like that. Like this is just running the raw models. So like there's ways to get it to fit onto your system. I'm just lazy, so I'm just running it basically out of the box.
We're just happy we're running.
So then for the code itself, your primary library that you're using is the diffusers library. So there's two main libraries that I use, or that most people use in the HuggingFace repo. And that would be the transformers library, which does most of your LLMs and your language models, tokenization, things like that. And then the diffusers are the ones that do art image generation and things like that. So usually you wind up sort of mix and matching them as well, because like, for example, in this instance, we wound up in one of the, I think it's in the video prompt, you wind up actually having to tokenize things, and that requires the transformers library. As well as there's also like some other outlier things like the sentence transformer library is really common. So in this case, we're using the diffusers library, and we're using a diffusion pipeline. So a diffusion pipeline is an abstraction of the core inference loop of like a machine learning model. So under the hood, there is like this big giant class that is filled with all kinds of different methods, and those methods perform like the different kinds of operations that we're familiar with in terms of looking at the models themselves, like gradient descent and things like that. with using the Hugging Face model, it's kind of good and kind of bad because like you don't work hands-on with that directly, but it abstracts it well enough that you can successfully get a machine learning pipeline up and running like as an individual in a day, like without any real problem. If you have like a team, you can make a really robust one for like a production ready and ready to scale setting. So it is quite impressive. The balance between the abstraction that Hugging Face has done and the ability to be able to actually use the code, because I find some libraries will over abstract things and then I get confused about how to use it and I don't know, like it doesn't explain it well enough. But Hugging Face does a really good job with their documentation, so I highly recommend it. So the first step of the process is generating. Oh.
Just let me interrupt. There was a question if we needed to pay Hugging Face to use it.
No, Hugging Face is 100% free, and almost all applications that try to make you pay for things are wrappers around Hugging Face, except for the ones that are wrappers around OpenAI.
Okay, so 2 ways of ripping you off. Great.
Yeah. Well, it's just sort of the nature of the thing.
Yeah.
When somebody figures something out, they tend to try to use the knowledge to make a living, which is fair. I mean, you got to make a living.
Yeah.
And then so for the main first step is going to be Stable Diffusion. And so that's using a Stable Diffusion XL, which is a diffusion model that is broken into 2 steps. So there's a base step that generates the core image, and then that sort of does like if you're thinking of it as like somebody chiseling a statue or something, they're sort of like knocking out the big pieces, and then the diffusion pipeline, the refiner pipeline, that is like the fine detailing where you're like going in and making all the lines like perfect and making sure you can see like the details in the hair and stuff like that. Hugging Face makes money off corporate consulting and services right now, so it's free for us. Yeah, basically, if you're not like a big giant corporation, you don't have to pay for a lot of this stuff, honestly. I have access to all this stuff because I'm kind of lucky, but I honestly got by without any real help from anybody, from things like the Google TPU grant system. Like there's a lot of resources that are available if you just like go and apply for them. And people are really nice, and the ML community is really like helpful. And there's lots of documentation and lots of people explaining how to do stuff because everyone's really nerdy and excited about it. So in this step, we load the base, and then we put that base into our device, which is in this case is a CUDA device. CUDA is a NVIDIA library, and that NVIDIA library is basically tells your GPU how to communicate with the memory that is allocated to it, so that it can perform really efficiently, and it will increase the speed up of your machine like in orders of magnitude. So if you have the ability to run CUDA, I highly recommend it. Don't try to use it without, because you'll wait 5 times as long. I mean, it's what the GPU is there for. So the other things that we're doing inside of here is we are calling in the models themselves. So there's 2 different models, like I said before. And then we're using a variant, and that's it's a 16 floating point average how do I explain that? So like each tensor is like an array of numbers, and then those numbers, they have a floating point decimal. So like it goes to 1.0000 or whatever. And it'll go to 16 points of resolution. So like if the standard is 32, so this is about half of that. So that increases decreases the amount of memory that is required, which allows you to run it on a smaller GPU. And then because you don't need that much like fine-grained detail information with the image generation pipelines as they are now, you don't really sacrifice any loss in quality until you start getting down into like the 4-bit and 2-bit when you're really, really compressing it. Continuing on, we load the second model into our GPU. Then we have the number of steps. So this is the number of steps that are being performed during the refinement and the base diffusion. And it's done here as a fraction, so it's a percentage, and then it's rounded off to a round integer. Because you can't do like 1.5 steps. You have to be able to complete the entire step. And then after that, we take our prompt.
Richard,
go ahead.
Yeah, so the fraction, is that the difference between the base and the refiner?
Yeah, that's the difference between the base and the refiner in this instance. Yeah.
So this would be 80% in the base and 20% in refiner. Is that what that is?
Exactly. So I think yeah, it winds up evening out to 27 and 8 when it actually goes and runs inference. So it's just basically like a lazy way, so you don't have to like try and actually calculate out what it is. It'll just do it for you.
Okay, and then the other question, the refiner, does that upscale or is it same resolution?
It's the same resolution.
Okay, just higher quality.
But there is a UNet in the architecture of the model, so it does. You can, if you want to get really good quality images, one of the tricks is to start out with a 2400 by 2400 or 2048 by 2048 image, and then have the target image size be 124 by 124, and then it will compress that during that U portion of the diffusion, and then it will come out with a higher quality image, which is kind of neat. And then we define our positive prompts and our negative prompts. Normally here we would actually pull in the transformer library and tokenize our input, but because this is a pipeline, so pipelines are specifically more abstracted than if you called the model itself. If you call the model itself, it is a class that is abstracted, but it has a lot of methods that you still have to manually execute. So tokenizing is one of the examples. So here you wouldn't have to actually tokenize because we're using the pipeline. The pipeline does it behind the scenes, and we don't have to worry about it, which means we also don't have to have another library installed. Well, we have to have it installed because it still uses it, but we don't have to have it like imported directly and explicitly, which is nice. And then we basically just run both of the models. So here, this is just basically saying, okay, run this, and then the output gets output to this images. And then we take a single image, and then we run it one more time, and then return a single image again. So it will.
What's the purpose of running that single image again then?
So one is the refiner, and then the other. Sorry, one is the base, and then the other one is the refiner.
Oh, okay, yeah. I'm sorry, I wasn't looking at the function names.
Yeah, no worries. It's just it's starting. It's just the two steps of the process. So it just does everything in parallel. So it's like load your prompts, load the models, run your inference. I guess load prompts again. I should probably put those two together. It'd make more sense. Yeah, and then that gets generated and then returned. Oh, go ahead.
Yeah, I had two questions there. So the first was dot images. So is the base generating multiple images?
Yeah, so it comes out in a batch. You can set the batch amount to higher than one amount.
Okay, I see. Normally, I get
that. Yeah. So if you want just a single image, you just select the first instance in the array, and in that there's only one, at least right now.
So there's an argument of some sort that would say the batch size is there if I want to generate 4 of them at a time.
Yeah, exactly. So where you would do that is in here is you'd just be I think it would probably be batch size. Yeah, so batch size equals 1, and then like you can put that up to like 9 or something if you wanted to make more.
Okay, and then the second question there, I see output type equals latent.
So we keep it in the latent space.
Okay, and then the refiner is going to convert it up to pixel space.
Yes, exactly. No. The refiner keeps it in latent space, and then we pass that latent into. Is that? Yeah, no. But we pass that latent into the vision model because it does image to image and it does it in the latent space. I'm fairly certain.
Gotcha.
David, yes. So your batch size is dependent on GPU and RAM size. So if you have a lot of room on your memory card, then you can do larger batches. Most people generally wind up doing like people really like to do 4 because it's like a nice round number. It makes a little block grid, and you can get lots of images quickly. Because like I find with AI art, it's not so much about like crafting the perfect prompt and getting it on the first try. It's about making like 500 images and picking the one that looks the best. So it's like it kind of it's I used to be a digital artist too, so it's kind of like a weird juxtaposition from spending like 3 weeks on a piece to like making 500 of them in a couple hours. It's a wild world. And then so from there, we go into the video diffusion. And the video diffusion is short and sweet, and it's very similar in structure to the Stable Diffusion. And like I said, once you learn sort of like how the flow of these pipelines works, there's pipelines for basically every kind of model. So then you can use almost all the different models. So it's a really powerful library to learn if you want to learn one thing for machine learning. I highly recommend the HuggingFace libraries because they have excellent documentation. They got videos that walk you through it. They have examples that they take you through step by step, and all of their stuff is all in the same format all the way through. So it's like it's phenomenal. So,
Richard, is the Hugging Face models you're talking about all image models,
no,
or do they also include language models?
yeah, they include language models. There's text to speech, text to image, text to speech to text, and then there's a translation model even. Like basically any model that has been made and put into the Hugging Face repo, which is basically every model because everyone uses it to store their models, has an implementation in the Hugging Face library. So for almost everything, yeah, this is the implementation that's behind the Stable 1111. Building my own computer, is it worth the extra $1,000 to upgrade to no, I don't think so. That's a lot of money for not a lot more. What's the difference between a 4080 and 4090 in terms of memory? Sorry, I'm just really curious now. 16 gigabytes versus
16 versus 24, yeah.
Oh, that's actually almost worth it. That's a lot of money for that upgrade though. I honestly would do neither, and I would get two 3090s. Because
use 3090s, right?
Yeah, use 3090s specifically from the crush. You need to buy the crush dreams of blockchain people.
I don't know what the cost of two 4080s compared to a 4090.
But they don't NVLink. They took that ability away. 3090s are the last generation that they can do that. Yeah, because they're buggers.
Yeah, but you still could use.
You could use two of them for sure, yeah, but it's just a little more legwork to get it running in parallel.
By the way, I have one of the early 3090s, and they're weird. They like don't fit in a regular PC. They're longer.
Oh yeah.
So be careful, like how big of a case you need for 3090s. If you're really going to follow Richard's advice.
Are you saying you have to get like you can't use a compact case? You got to get a full size one, or server, or what are you saying?
No, like even a regular standard full-size case, it may not fit.
Oh, like one that's as big, goes up to the top of your knee, it may not fit.
Yeah, I mean, it's not the width, it's the length.
It's the length.
Yeah, the depth of the card, right? On the motherboard or whatever.
I just have mine living in a test bench that I'm too lazy to put into a case.
Well, maybe you wouldn't be able to anyway, according to what Ted said.
All right, so the last of the code for the main video generation is basically, it's very straightforward now that we sort of have a grasp of how the image to image, the image generation works for the first step. But here we're just using a video model, and this is a specific video model that's been trained by Stable Diffusion. I did not take the time to read the papers, otherwise I would be able to explain it a lot better. But let me just pull up the repo. Stable video, image to video. That's that. So this is the repo that it's pulling from, and you can see like it does like quite good images. And it does like timelines really well. That's the thing that impressed me the most, is that because in previous iterations of image or video generation that I've used, the between each frame is quite dramatically different. So it would be really choppy and sort of like it looks like kind of weird. Like I can show you one of my first ones that I did. And it like you can it's like super duper it's like really cool because it's like the first time I ever did it, but you can tell it's like it's really weird. And not like normal art, like not a normal video. It's quite clearly AI. Let me see here. Where's that? Oop, can't see anything. Grab this thing. But in terms of this model, it looks like frame-wise decoding. I'm not sure. Models trained to generate 14 frames. Yeah, so it's like it's trained to like specifically do a specific amount, which I find interesting. Yeah. Oh God. Oops. I forgot there's music on that one. Mute that. Play this. But you can see the video to video is like quite weird and like very like it interpolates a little bit, but you can see like in between each frame, like it's not very stable. And so that's one of the first things that people were trying to fix. And so the Stable Diffusion video model is the first one that I found that just does it out of the box quite well, where you can do things like have a rocket that's launching into space, and it looks like the rocket's launching into space, which is cool. And then, so for the code, is this the right place that I'm in? Yes, okay. Basically, we are just grabbing the stable video diffusion pipeline this time. So same idea. And then we're going to use a video. You can also use an image, a video to video if you want. That is an option. I have it set up here so that you can do that. You just have to pass in the video instead of the image. Oh wait, no, sorry, that's the output path. I'm wrong. It's just that it takes the image. And this model only takes image to video. It doesn't do text to video, which is why we did the previous step of generating the Stable Diffusion, Stable Diffusion XL image, so that we can feed it into this step. And then you can set your parameters here, and then we load the model. And again, we're going to use the floating point 16, and then load that into our memory card. And then we condition the image. So conditioning is a step that we didn't do well, we did it, but it's obscured by the pipeline in the previous text to image step. It basically will use like a text encoder to look at what the prompt is, and then use those encoding or those embeddings to be able to inform the diffusion model of what it's supposed to be generating. In this instance, it's doing something similar, but it's doing it to give the images continuity between the image that comes from behind and before, and sort of like links the images together. So it's basically it has like a like an extra dimensional space in terms of the way that it's communicating how to process the image, if that makes sense. Did I explain that right? Got it, thanks. I'm building an AI lab for my university. In terms of pricing, what's better, 3060s with 16 gigs? Because you can stack them. Yeah, I also think 3060s are a pretty good deal. Specifically just because they can NVLink, and you can get like 32 gigs of RAM is a reasonable amount of RAM. Like you can run most 7 billion parameter models with that. So and then if you quantize things, and the bloke is amazing for that, you can almost always find a model that you'll be able to fit. So then we resize it because it's trained on a specific size of image. It's very important that you have that size of image. If you don't, it will distort the image and it will look really wonky, and like it's it sort of looks like you're in like a weird shaped hologram, and it doesn't. It looks like in a funhouse mirror or something like that. And then we take those, and then we break that up, and then we put them into frames, and we fire that into our pipeline. and then we generate it, and then we have a video. And that's like the basic of like how the pipeline works. I'm not sure if does anybody have any more questions? Why not rent a GPU at like Paperspace or something? Yeah, it just depends on what your means are, right? Like some people, and also how much you're going to use it. Like I don't know, like $600-700 for 32 gigs of RAM for a GPU, then you can generate images and text whenever you want versus having to sign up for RunPod or something. I personally like just having the ability to do it. But also it's not within everybody's means all the time, so I do understand that. Yeah, so that's basically that. And then thank you for letting me present, I guess. And also sorry that I didn't get the instances running. I'll try and get them running, and then I'll post them in the channel so people can play around with it on their own. But yeah, thank you.
Thank you, Richard.
Thank you. That was really cool. It's always good to see all this theory actually does produce something at the end of the day that we go through, things like that. And good tips on the
So-
used GPUs.
So Richard, if we run a session where we can open up the connections that you were trying to, were those connections to notebooks or to VMs, or what were they?
So I have two different things. My notebooks didn't work today, which was the thing I wanted to do. I wanted to have because I have a Jupyter Hub instance, and then I can just generate notebooks and people can just use them. So it's very convenient for this kind of stuff. But when I went to go check it today, it didn't work. So
Okay.
I wound up, my backup option is we do have, we host some data scientists that use Jupyter, VS Code instances. So in that case, I made everybody a folder with the same repo, and then we were going to just use a notebook to take the code from that repo and then like implement it ourselves. That was the plan. So.
Okay.
Do you think we could do one of those sometime in the future then?
Oh, 100%. Yeah. I'll make sure that I put more than like I just got the week got away from me, so I just ran out of time. So.
Yeah, we fully understand. It happens to probably every week to everybody.
So maybe if like if we schedule that next week or something like that, we could have somebody jump in on Tuesday or Wednesday or something like that and try
Yeah, and
an
just
instance
test
ahead
them
of
all
time.
out. Yeah, that'd be great.
Yeah.
Yeah, I'd be happy to do that, if you're available, Richard, in case I have any questions.
Yeah, was there any particular type of inference people wanted to see? Because I have text to speech, speech to text, text to image, and then I have like a bajillion comfy different implementations, or like Stable Diffusion implementations, and then I think that's about it. Oh, I have a Mamba model too that runs, which is cool.
Wow.
And I have Grok too, which is, but I don't think I could let people on that machine because it's the H100. So, but I could show it. It's not very impressive because it's not fine tuned and it takes forever to generate any inference.
Yeah, that was on the Grok machine though.
Yeah, that was on the Grok machine.
Okay.
But it fully loaded like 8 H100s, and it took 15 minutes to generate like a babbling nonsense.
Oh, geez.
Yeah.
So Richard, do you have pre-trained weights for Grok or no?
That's the problem. I don't have pre-trained weights, and the computational resources that are required to fine tune it are a little bit like I have the ability to do it, but it's not like wise for me to do it, if that makes sense.
Oh yeah, no,
Yeah.
I understand. From scratch, it's gonna take a long time.
We did just have a really interesting breakthrough with one of our data scientists that implements a like cross-platform implementation that allows Petals, which is like a distributed network, to work with GRC TPUs, and they give you grants really easily. So we have a grant with them, and so I think we could train it on that. So I'm going to take a look at implementing that, because if I can get a nice set of fine-tuned weights and just give it to everybody, that'd be great. Because like, no, I don't think anybody's going to be able to do it really easily. So
Cool.
Yeah, I don't know how Grok will go, but I thought that a lot of these LLMs, you're still talking about like a TPU year of compute.
Yeah, that's why with the grant you can get 10 of them running at the same time. Actually, you can get 100 because you can have the preemptible instances, and those will you can use them one time and then they expire. So you theoretically could just do like one massive run. It would be terrifying, but I got to have ops guy. He knows what he's doing.
Are there other smaller language models that are easier to bring up?
Yeah, so I have a really nice implementation of the Llama CPP. And it's basically you just bash a script and it will like deploy an entire API and give you an example of generating inference. So we could do that if you want.
What do you think, guys? Or everybody? Sounds good to me, but maybe I don't know it well enough.
Well, and then you could also like do like prompt crafting stuff too, like because like it doesn't. One of the things that's really you need to learn how to do for implementing language models is out of the box. The models don't have context windows and they don't have any kind of memory management system. So you need to be able to implement that. Otherwise, it's basically useless. Because if you can't follow the flow of conversation, you can't follow up on questions and stuff. Every single time you ask it a question, it's as if it's the first time it's been asked, and it's very, very annoying.
Got it. Got it. So it doesn't have any memory essentially of what it did 30 nanoseconds ago.
Yeah, it's like if you ever seen Memento, where the guy like loses his short-term memory and he like lives his life by like writing sticky notes on himself. Like the context that they get is like his sticky notes. Like
okay.
Richard, you know that you can have two kind of model these instruct models that works as chat models, like you can have assistant user and assistant user model.
Yeah, that's
And
the standard OpenAI protocol.
yeah, but these models you're talking about are just generating model like the legacy models, generating text that like the legacy models, or are already fine-tuned to be like assistants.
Yes, so the instruct models are a fine-tuned variant of the base model. So the foundation models will be the non-instruct versions, and then the ones that do the assistants and system messages and all that stuff, those are they've been fine-tuned beforehand to allow them to accept that, and also just to get them used to talking in a conversation, because it takes a little while for them to sort of ramp up and like understand that they're in a conversation if they're just the base weights.
So that llama one sounded interesting. Maybe for next time. Would you be able to do that next week or?
Yeah, for sure.
Yeah. What do you think, guys? Everybody? I think that's a good idea. I don't know about anyone else. Yeah. Okay, I'm seeing a lot of thumbs up here, faces nodding, heads nodding. So if we could look at that, I mean, I hate to ask. I know it takes a lot of your time and things like that.
Oh no, I just am happy. I'm sad that people weren't able to use the machines. Honestly, I just want I want to be able to share all this stuff because it's super cool, and like not every day you get to play with the A6000. So like it's
yeah. You're working in a different space than I think most of us are in terms of a resource type thing.
I'm just really lucky and met some really crazy blockchain people that have way more money than sense.
Hey, but it's blockchain, man. They got crypto coming out the yin, so you know.
As long as it keeps going up.
Yeah, I guess so. Okay, so why don't we plan that for next week then, if that's cool with you, Richard?
Yeah, that's cool with me.
Okay, everybody cool with that? Sounds good. I just wanted to get that done before we kind of wander off into our typical conversation.
Hey, I thought I would maybe share a quick comment about the HuggingFace models and kind of what they do. So one other thing, if you have a model that's in HuggingFace format, what that means is that they've named all of the layers in a very specific way, and they've named all the like trainable weights in a specific way. because there are certain things that you might want to do. So for example, Roger did multiple sessions where he was talking about parameter efficient fine tuning, right? So if you want to do LoRa, QLoRa, whatever, you are sort of attaching things to different parts of the model. Certain models you might be able to deal with like different sizes of things or whatever. And a lot of the way that the bolt-on stuff works is it has to be able to find the things inside of your model. So let me find the, you know, the fully connected layers. Let me find the query weights for your attentions or this or that or whatever. And so just so you know, if you just have any old model that's perfectly normal, works great, you cannot necessarily apply things like the HuggingFace parameter efficient fine tuning stuff, because how those models are designed is they look for things that are named a certain way. So I thought I'd just throw that out there. So as long as you stay within the HuggingFace ecosystem, it's really great. Stuff tends to be just plug and play.
Yeah, it's very not mix and match. That's for sure.
Yeah.
Especially because like implementations of even just between like Mistral models and Llama models and like GPT models and T5 models, like they're all different and they all accept different kinds of inputs and stuff. And it gets very complicated because you're switching from one thing to another, and you have to know what types are what and what shapes are what, and it gets very complicated.
Yeah, yeah. And so like I chat with people that are doing a lot of interpretability stuff. And so it's like, oh, let me just see what like it's a 24 layer model. Let me see what it looked like after only 12 layers. It's like, but it's not named what I thought it was named. So you just get a big error message when you say, what's the value, you know, after layer 12. It's like, there is no object called blah, blah, blah layer 12. Ugh. So.
They've spec'd that though, right? They must have some sort of spec for their naming conventions and things
Yeah,
like that.
there's really quite extensive documentation, and their errors are for the most part pretty good. If you just read the messages, which is the hardest part, then then you'd be able to figure it out.
Yeah, but I just thought I'd bring that up because like people have experienced the pain where it's like, oh, Joe Blow has this awesome implementation of fill in the blank, you know,
But it
a
only
mama
works for
model,
him.
a
Yeah.
Bamba, you know, adapted to do this, a blah blah blah, right? It's like, yeah, that's great, but just all that other stuff might not work with it.
So it's a plumbing problem more than a technical problem.
Exactly.
Yeah.
Yep.
Yeah. Yeah. Okay.
It's can you fit it into the pipeline?
Yeah. Yeah. Well, you know, or then in this case, the naming convention within the pipeline. So yeah, I could see that.